Given the points A, x1, y1, z1 and B, x2, y2, z2, the vector A with representation AB is B minus A, x2 minus x1, y2 minus y1, z2 minus z1. In this diagram, point A, x, y, z, point B, x plus a1, y plus a2, z plus a3. Vector A, B will be x plus a1 minus x, y plus a2 minus y, z plus a3 minus z, that is a1, a2, a3. Example, find the vector represented by the directed line segment with initial point a 2 minus 3 4 and terminal point b minus 2 1 1. The vector corresponding to AB is b minus a minus 2 minus 2 1 minus minus 3 1 minus 4. Simplify it and we'll get minus 4 4 and minus 3. The magnitude or length of the vector. The length of two-dimensional vector a1, a2 is magnitude of A is equals to root a1 square plus a2 square. The length of the 3D vector a1, a2, a3 is magnitude of A is equals to root a1 square plus a2 square plus a3 square, square of each component and root. Example, if A is equals to 403 and B is equals to minus 215, find magnitude of A and the vectors A plus B, A minus B, 3B and 2A plus 5B. 1, 2, 3, 4, 5 parts. So we start from A magnitude is equals to 4 square plus 0 square plus 3 square. Simplify, it will get root 25. The length of A is 5. Next part, A plus B. Write A and then write B. 4 minus 2, 0 plus 1, 3 plus 5. Simplify it, 2, 1, 8. Add the respective components. A minus B. 403 minus minus 215. 4 minus minus 2, 0 minus 1, 3 minus 5. Simplify it, we'll get 6 minus 1 and minus 2. 3b. 3 times b, which is minus 2, 1, 5. 3 into minus 2, 3 into 1, 3 into 5, and we will get minus 6, 3, 15. Last part, 2a plus 5b is equals to 2 into a plus 5 into b. 2 times 4, 8. 2 times 3, 6. 2 times 0, 0. Plus 5 times minus 2, minus 10. 5 times 1, 5. 5 times 5, 25. Add these two. 8 minus 10 minus 2, 0 plus 5, 5. 6 plus 25, 31. Example, if A is equals to I plus 2j minus 3k and B is equals to 4I plus 7k, express the vector 2A plus 3B in terms of I, j and k. 2 times A, replace B. 2 times 1, 2. 2 times 2, 4. 2 times minus 3, minus 6. Plus 3 times 4, 12. 3 times 7, 21. Add the respective components I with I, j with j and k with k. 2i plus 12i, 14i, 4j as it is, minus 6k plus 21k plus 15k. I, j and k. I is equals to 1, 0, 0, j is equals to 0, 1, 0, k is equals to 0, 0, 1, I on x-axis, j on y-axis, and k on z-axis. A unit vector is a vector whose length is 1. For instance, I, j, and k are all unit vectors. That is, the length of I, j, and k is 1. In general, a is not equal to 0. Then the unit vector u is equals to a over magnitude of a. Example, find the unit vector in the direction of the vector 2i minus j minus 2k. So the length of the vector is root 2 square plus minus 1 square plus minus 2 square. Simplify it, root 9 is equals to 3. We have length of the vector. Now to find the unit vector, vector divided by the length of the vector. And we will get 2 over 3 minus 1 over 3 and minus 2 over 3. The dot product or scalar product. So if A and B are two vectors, then the dot product of A and B is written as A dot B is equals to A1 times B1 plus A2 times B2 plus A3 times B3. And if theta is the angle between the vectors A and B, then A dot B is equals to length of A times length of B into cos theta. Example, minus 174 times 62 minus 1 over 2. So we have to multiply them. Minus 1 times 6, 7 times 2, 4 times minus 1 over 2, and add all of these, will get 6. I plus 2j minus 3k dot 2j minus k. I with I. There is no I, so 0. Plus 2 into 2 plus minus 3 into minus 1. Add all these, will get 7. Example number 2. If the vectors A and B have lengths 4 and 6, length of A and B is given, and the angle between them is pi by 3. Find A dot B. A dot B is equals to magnitude of A times magnitude of B into cos angle between them, which is pi by 3. So length of A is 4, length of B is 6 times cos pi by 3 is equals to half. Simplify it, will get 12. Example, find the angle between the vectors A and B. Now we have two vectors and we have to find the angle between them. To find the angle, start with the length of A. 2 square plus 2 square plus minus 1 square is equals to 3. Length of B, 5 square plus minus 3 square plus 2 square. Simplify it, root 38. Then A dot B, 2 into 5 plus 2 into minus 3 plus minus 1 into 2. Simplify it, will get 2. The angle between them is cos theta is equals to A dot B over length of A times length of B. A dot B is 2, length of A is 3, length of B is root 38. To find the angle theta, cos inverse of 2 over 3 root 38 will get 1.46 radian or 84 degrees. Two non-zero vectors A and B are called perpendicular or orthogonal if the angle between them is theta is equal to pi by 2. A and B and the central angle is 90 degrees. A dot B is equals to 0 or theta is equals to pi by 2. Two vectors A and B are orthogonal if and only if A dot B is equals to 0. Example, We have to show that these two vectors are perpendicular to each other. And to show it, we do A dot B. 2 times 5 plus 2 times minus 4 plus minus 1 times 2. Our answer is 0. It means that these two vectors are perpendicular. Example, a wagon is pulled a distance of 100 meters along a horizontal path by a constant force of 70 Newton. The handle of the wagon is held at an angle of 35 degrees above the horizontal. Find the work done by the force. Work done is equals to force into displacement. So F dot D is equals to length of F times length of D into cos of angle between them, which is 35 degrees. Force 70 newtons, displacement 100 meters, and cos 35. We'll get 5,734 Newton meter, which is joule. A force is given by a vector F and moves a particle from the point P to the point Q. Find the work done. The displacement from P to Q. So the displacement D is equals to PQ will be 4 minus 2, 2, 6 minus 1, 5, 2 minus 0, 2. Work is equals to force dot displacement is equals to 345 dot 252. 3 times 2, 6 plus 4 times 5, 20 plus 5 times 2, 10. Simplify it and we'll get 36 joules. Recommended reference book or textbook for this course is Calculus Metric Version 8th edition by James Stewart. This is the end of the lesson. Thank you.